Kepler's law and communication satellite, and then we'll start with MCQs. Today you have test on that 1 to 200 MCQs. Have you practiced that once again? Whichever was difficult for you?
Yes, sir.
Okay. Kepler's law. As per this law, first law states that the planets revolve in elliptical orbit. The planets revolve in elliptical orbit around Sun with Sun planet revolves around Sun in elliptical orbit. So whenever it is given planet revolving, it is not circular. Satellite revolving, it will be circular. Planets revolve in elliptical orbit around Sun with Sun situated at one of the foci. Second law, which is important for calculation purpose. If this is elliptical path, this is Sun situated. So if anywhere here is planet, it moves from P to Q in some time t, and then M to N in same time. Then law says that area transversed in the same time will be same. That is called aerial velocity is same. The aerial velocity, that is area swept by radius vector in same time, is always constant. Now why that aerial velocity is constant in same time? Area of sector, is it half length of arc into radius? If you know, half LR is called area of sector. Hello?
Yes, sir.
So length of arc L is r theta. That means I can say A is half r square theta. So dA upon dt will be half r square d theta by dt. This is nothing but half r square omega. If I multiply by m and divide by m, then mr square omega is I omega, which is called angular momentum. So we know that angular momentum is always constant if no torque is acting. So this aerial velocity dA upon dt is L upon 2m will be constant. Just write this two law, then third one I am writing.
Done, sir.
Okay. Third one. It is also called as law of period. Square of time period is directly proportional. Square of time period is directly proportional to cube of semi-major axis. If this is ellipse, longer axis is called major axis and the smaller is called minor axis. Half of this is called semi-major axis. So square of time period is proportional to cube of semi-major axis. This is Kepler's third law. Right.
Done, sir.
Communication satellite. A satellite which revolves in an equatorial plane of Earth in circular orbit with time period of Earth's rotation, that is 24 hours, is called as communication satellite. A satellite which revolves in an equatorial plane of Earth in circular orbit with time period of Earth's rotation is called as communication satellite. It is also called as geostationary satellite because it appears to remain stationary from any point on the Earth. Geostationary satellite or geosynchronous satellite or parking satellite. So geostationary, geosynchronous, parking satellite, communication satellite, all are same to same. Remember, it is time period is 24 hours. Its height is nearly 6 times r from surface, or 7r from center. That is nearly 36,000 kilometer from surface. Its velocity is approximately 3.09 kilometer per second. Right, this much. Now we can start with MCQ. Shall I clear?
Yes.
Now, gravitation sheet I have given you.
No, sir.
No, na. 1 minute. I'm just saying. Gravitation I have not given. You are saying. Ashlesh, I had done this chapter earlier. Gravitation.
Yes, sir.
I might have sent you. I think.
Sir, I also have it.
I have 1 minute. I will search.
So is it the same sheet?
Ah, same. I have to resend. 1 minute. Gravitation I had took earlier. Gravitation.
Sir, I just sent a sheet that I have.
You have gravitation? Yes, I got it. Thank you, Ananya.
No problem, sir.
Gravitation. Come to page number. I'm going reverse this time. Page number 42. Come to that page. Reverse I'm explaining. Some number 110. The gravitational field due to two bodies of masses 900 kg and 1600 kg placed at distance 10 meter is 0. Then corresponding distance of the point from larger will be how much? So distance from larger, suppose it is r, then from smaller it will be 10 minus r. We want that distance where field is 0. So for field to be 0, this is attractive here E2, and here E1, it will be 0 if E1 is same as E2. So G into mass of M1 upon 10 minus R square is G into mass of M2 upon R square, where field will become same. G cancel. So 900 upon 10 minus R the whole square equal to 1600 upon R square. Two zeros you cancel, then take square root. 3 upon 10 minus R is 4 upon R. So 3R will be 40 minus 4R. 7R equals to 40. R equal to 40 by 7. 40 by 7 meter is the distance where field will become 0. Option A. 40 by 7.
Done, sir.
109 try. One zero nine. A body is projected up with velocity equals to 3 upon 4 times that of escape velocity from the surface of earth. Then height h reached will be how much if r is the radius of earth? 1 minute, look. Is vp less than v? Vp is less than v.
Yes, sir.
Yes.
That means it will reach up to some height nr and stop. So जब भी ये concept आया तो what I had explained you, n upon n plus 1 mgr is half of m into velocity of projection square. So n upon n plus 1 mgr is half of m, velocity of projection is 3 upon 4 of escape square. So this will become n upon n plus 1 mgr equals to half m, 3 square 9, 4 square 16. This is 2 times gm by r. Okay, 2 cancel. So n upon n plus 1 mgr is 9 by 16 r square g upon r into this small m. R cancel. So throughout this mgr also cancel. So 16n is 9n plus 9. 7n equals to 9. N equal to 9 by 7. Since h equal to nr, so it is 9 by 7r. I hope followed. Method followed now? Yes, Aryan followed. Aryan saying
Yes, sir. Got it.
ये मेथड से करना, दूसरा मेथड लेंदी होगा. 9r by
Okay.
अश्लेषा आफ्टर क्लास वेट है, खाली मुझे चेक करना है आपका क्या बाकी है पढ़ा के.
Yes, sir.
Done, sir.
108 you should try on your own. I will wait for your answer. Try.
R by 3, sir.
How much? R by 3.
R by 3.
Others are also getting same R by 3.
Yes, sir. Yes, sir.
Yes, sir.
So R by 3 is correct option. Now if they ask from the center, then you will add R in that, huh?
Yes, sir.
107 I am doing. 107. A body is projected up from the surface of Earth with velocity m times v, where m is less than 1. So same formula. If r is the radius, maximum distance from the center they want this time. So my h is nr. Distance from center will become r plus h. This is what we have to calculate. Now n upon n plus 1. Mass is m. I am writing m naught to avoid the confusion. Is half into mass m naught into escape velocity projection square. So m naught we can cancel. N upon n plus 1 gr is half of velocity of projection is m times velocity of escape square. So it will become n upon n plus 1 gr is half of m square 2 times gm by r. Gm by r is same as gr. So this will become n upon n plus 1 gr, 2 cancel, m square r square g upon r cancel. So it is n upon n plus 1 gr equals to n square rg. You can cancel rg, m square. So we get n equals to m square n plus m square. Therefore n minus m square n is m square. N common, 1 minus m square equal to m square. Therefore n equals to m square upon 1 minus m square. Now distance from center is r plus h, which is nr. So it is r plus n m square upon 1 minus m square into r. So finally it will become r common, 1 minus m square plus m square upon 1 minus m square is cancelled. So r upon 1 minus m square. Hello? R upon 1 minus m square. Option D. Correct now?
Yes, sir.
Okay. Completed? 108? 107?
Yes, sir.
Come to 106. 107, everybody is done?
Yes, sir.
Yes, sir.
Yes, sir.
106. The masses and radii of Earth and Moon are M1, R1, M2, R2 respectively. Their centers are at distance d apart. Masses and radii of Earth and Moon are M1, R1 and M2, R2 respectively. Their centers are at distance d apart. The minimum speed with which a particle of mass small m must be projected midpoint from this, so distance will be d by 2, mass m must be projected minimum velocity so that it escapes. Okay, now if it is escaping, then binding energy due to earth plus binding energy due to moon should become kinetic energy of escape. This is the meaning. Binding energy of earth is g m1 m g mm upon 2r na formula. So it will be g m1 m2 upon 2. Distance from center is d by 2. What is formula for binding energy? Gmm upon 2r. Hello? Formula for binding energy? Gmm upon
Yes, sir.
2r if it is orbiting, and Gmm upon r if it is at rest. Because it is at rest, so Gmm upon 2 distance is d by 2 plus G m2m upon distance 2, sorry 2 nahi, khali d by 2 r because it is at rest. Kinetic energy is half m into velocity which we want. Throughout this m cancel. So it will become 2 times G m1 upon d plus 2 times G m2 upon d equals to half of escape square. So 2 comes here, 4 times G upon d I can take common, m1 plus m2 equals to escape square. So escape is root of 4g by d m1 plus m2. Now I'm looking option how it is given. 2 they have brought outside. We can g common m1 plus m2 upon d power half. That is given in option B. So 106 option is B.
Done, sir.
105. Period of revolution of Earth's satellite close to the Earth. Period when close to the Earth is 90 minutes. Close to the Earth means radius of orbit is r. For another satellite at a distance 4 times the radius of Earth from the surface. Radius 4 times from the surface means from center it is 4r plus r. What will be its time period? Period of revolution of Earth satellite close to the Earth is 90 minutes. Period of another satellite at distance of 4 times the radius of Earth from its surface. From its surface 4r, from center it will be r. Will be how much? Can I say t square is proportional to r cube? Hello?
Yes, sir.
So t1 upon t2 square is r1r upon 5r the whole cube. Here only chance of mistake, will take distance as 4r, but from center it is 4r plus r, because 4r is from the surface. R cancel, 90 upon t2 cube equals to 1 upon 5 cube. 5 cube is 125. So 90 upon t2 is 1 upon root of 125. So t2 will become 90 into 5 root 5. 90 into 5 is 450 into root 5. Something wrong? The period of revolution of Earth's satellite close to Earth's surface is r. Then time period of another orbit at distance 4 times the radius of Earth from its surface will be 5r. 125 is cube, square root 5, 5. 450 into root 5. Root 5 is close to 2. 64 into 8. In orbit at distance 4 times the radius of Earth. एक मिनट है, उधर वर्डिंग रॉन्ग है. In an orbit at distance 4 times radius of Earth. In an orbit from its surface word नहीं आना चाहिए, फिर आ जाएगा आंसर. ये 4r, that will become 64. 64 square root is 8. 720 is the answer. 4 times the radius of Earth चाहिए खाली. So 720 is required answer. That is C. After this 104. 104. If you know that formula which we did yesterday of intensity, then gravitational force you can find between them. So gravitational force is intensity of that ring into mass capital M. Intensity of ring is force acting on mass capital M. So E into M. What is formula for intensity of ring? Gravitational intensity? G. Hello?
GMD upon D square plus R square.
Yes.
Raised
D
to 3
square
by 3.
plus that distance. No, D square plus R square raised to 3 by raised to 3. 3 by 2. So G M distance D is root 3a. Root 3a. This is a square. Root 3a the whole square plus a square raised to 3 by 2. So root 3 G M A upon 3a square plus a square raised to 3 by 2. That will become root 3 G M A 4a square raised to 3 by 2. So root 3 g m a upon 2a the whole square raised to 3 by 2. 2a the whole square raised to 3 by 2. 2 will get cancelled. So I get root 3 g m a. 2 cube is 8 a cube. So root 3 g m upon 8 a square. So force will become root 3 g m into capital M upon 8a square. Check whether we have this option. Root 3 g mm upon 8a square. Option D, correct? Hello? Option D, okay?
Yes, sir.
So difficult if I don't know formula. Completed?
Yes, sir.
Okay, 103. 103, I have already explained. Please try 103. Let me see whether you are leading to correct option. What you got? If anybody is confused, tell me, then again I'm explaining.
So option D.
Yes, correct. Option D. All of you got same option D?
No, sir.
Have you tried it?
Yes, sir.
So 1 minute, then I have to explain again. चलो मैं बिगर डायग्राम का समझा देता हूँ अगर आपको याद है तो. नेट फोर्स एक्टिंग एट वर्टेक्स, नेट फोर्स रिजल्टेंट कितना आएगा? √2 ऑफ ये दोनों फोर्स ना. देखिए
Yes, sir.
फर्स्ट सेकंड थर्ड फोर्थ. So √2 of force acting on this F41 plus F between 2 and 4. Correct? No? This resultant. ये समझा आपको?
Yes, sir.
So that means it will become √2 Gmm upon distance between 4 and 1 is side square. So I'm writing a square plus along the circle of radius r. Okay. अभी ये circle का radius r दिया है. ये बोला है radius r है. So we'll ultimately convert in terms of a and r. Now 2, 4 is nothing but Gmm upon √2 into side the whole square. So this is Gmm upon a square √2 plus 1 upon 2, which will become Gmm 2 √2 plus 1 upon 2 into a square. Now m v square upon radius, which they are telling r, equals to Gmm upon a square 2 √2 plus 1 upon 2. One mass I can cancel. So v square upon. What is radius? Radius of orbit is how much? Half of length of diagonal.
Yes, sir.
This is radius, na?
Yes.
So radius is half of length of diagonal. So it will be half of √2 into diagonal is half of length of diagonal, √2 into 8. That is equals to कितना लिखो? Because A we have to rectify, not R. R में आंसर दे. कितना लिखो? अभी 2 मिनट में आएगा. R is half of √2 into A. So R is A upon √2. A is R √2. So V square upon R is G M upon A square, which will be R square into 2, 2 √2 plus 1 upon 2. So 1 R cancel. Therefore, V will become root of G M 2 √2 plus 1 upon 4, option D. Okay now?
Yes, sir. Got.
102 graph है. Acceleration due to gravity with depth h from the surface of earth will be. Can it be curve or depth? No, no, because it is linear graph. कौन सा right है? Which of the following graph shows the variation of acceleration due to gravity g with height? As you go down, 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 acceleration increases or decreases? Hello?
Decreases.
It is decreasing, correct. And you move up, then also it will decrease. When we go down, then also it will decrease. But we know depth ka formula is G into 1 minus D by R. That means G at depth is G minus G D by R. So this is constant. Y at this is taken along y axis. This is constant minus constant into D by R. D is our x. So y is constant k minus kx. तो ये किसका ग्राफ है? Y equal to mx plus c वाला है ना? Where slope is negative. So will it be like this? Hello?
Yes, sir.
So that means option B. One not one. I want you should try this. Two body ka bhi also I have explained you.
So option C.
Option C, yes. Looking at that also you can say because we have done this. Option C, correct. Others also got option C.
Yes.
Yes, sir.
Last one do for today, 100th wala. At what height above the surface of Earth value of acceleration due to gravity will be half the value on the surface. So this formula you can use. GH is half of G on the surface. At what height G will be half that on G on the surface. So this is GM upon R square equals to half of GM upon capital R square. That means R will be root 2 R. R will be R plus H equals to root 2 R. So H will become 1.414 R. 1.414 into 6,400. Multiply. No,
B,
0.4. 0.4. Root 2 R minus R is 0.414. How much you are getting, you are saying?
2650.
Correct. 2650 is correct. Option. So today we stop here. After your test, 1 to 40 sums of gravitation homework for you. 1 to 40 from the top. Because they are easier, so you can easily manage. 1 to 40 you have to complete. So that's all for today. 1 to 40 if you can complete, then I think by Sunday we can complete this chapter.